Hello, and welcome to section 1.10. This is a little bit of a long section, so most of your videos are very short. This one might be just a little bit longer, but we're talking about some important features of the atom, and it's called isotopes and ions. So this is just a quick review. Remember our subatomic particles, protons, neutrons, electrons, what their charges and relative masses are, and where they're located in the atom. Remember, the proton tells us the identity of the atom. An element's atomic number is equal to the number of protons that that element has. The atom that has 9 protons is fluorine. The atom that has 10 is neon. The atom that has 11 protons is sodium, and so forth and so on. So here are a few more important details. A neutral atom, and this should make sense to you, it always has equal number of protons and electrons. If the atom is neutral, it obviously has to have equal numbers of positive and negative charge. And the proton is the positive charge, the electron is the negative charge. So here we have a neutral atom. Actually, it's lithium because it has 1, 2, 3 protons. And that atom will, if it's neutral, it will have 1, 2, 3 electrons. And the way we write some of these conventions is listed right here. You'll notice this on the periodic table as well. There are a couple of different ways to write this, and I'll show both of them to you. Here, we're going to look at helium. We will write the elemental symbol here, capital H, lowercase e, for helium. We write the atomic number up at the top right here. Helium has 2 protons. Its atomic number is 2. We write the atomic mass down here. The atomic mass is basically the number of protons plus the number of neutrons, because you know that protons are equal to 1 atomic mass unit, neutrons are equal to 1 atomic mass unit. So that's where we get the mass that in our atom is from the protons and neutrons. So if you look at this, you can see that the mass is 4. That means that we have 2 protons. We must have 2 neutrons in order to get to an atomic mass of 4. So you can try this. Here I gave you some information about magnesium. And we'll talk about this a little bit later, but for the most part, we will round this number. So 24.305 is going to be rounded just to the whole number of 24 for the purposes of what we usually do. So here are some questions. What is the atomic mass of magnesium? What is the atomic number of magnesium? How many electrons does magnesium have? How many neutrons does magnesium have? If lithium has 4 neutrons and an atomic number of 3, what is the atomic mass of lithium? So pause the video, see if you can answer those questions, and turn it back on and see if you get the right answer. Okay, here are the answers. We know the atomic mass of magnesium is going to be 24 when we round that number. We know the atomic number is 12. It's right there. Since the atomic number is 12, that means it has 12 protons. And since we're talking about a neutral atom, it's going to have 12 electrons as well. How many neutrons does magnesium have? Well, it will be the mass, 24, minus the number of protons, 12. We get 12 atomic mass units that are unaccounted for. That would be the neutrons, so it has 12 neutrons. If lithium has 4 neutrons and an atomic number of 3, what is the atomic mass of lithium? Well, it has 4 neutrons and an atomic number of 3, so it must have an atomic mass. We don't need this to do this, just 4 plus 3. It's 7. Those are the only things that have considerable mass in the atom. All right, here is another way that elements can be written. So you may see it like this. You may also see it like this, where we write the symbol for the element, chlorine, right there. And we write the atomic number here in a subscript right before it, in front of it to the left, and then a superscript to the left, so directly over the subscript, we write the atomic mass. So you may also see it like this. It should be obvious to you that the atomic mass will always be larger than the atomic number. So if you ever get confused, you can just remember that you can't have a mass that is smaller than the atomic number. So how do we get a hydrogen atom that has a different mass? It's called an isotope because it has a different number of neutrons. Here's an example. All of the elements have multiple isotopes that exist, and for the most part there is one that is predominant, but there are rare isotopes that exist of every element. Some elements have more than others. Here, let's just look at hydrogen and see how this works. So our most common hydrogen has one proton. Okay, there are in existence what we call deuterium isotopes of hydrogen, and they have one proton plus a neutron. There are also tritium isotopes that are even more rare, and they have one proton and two neutrons. So when you get an element that has a different number of neutrons than the common atomic mass is indicating, it would be an isotope of that element. So you try a little problem here. I'm going to give you cobalt, okay? And I'm going to give you some information. The atomic number is 27 and atomic mass of 60. So find the number of each of the three types of subatomic particles for this isotope of cobalt. And the answer is the number of protons is 27. That's its atomic number. The number of electrons is 27 because it's neutrally charged. There's no charge on this element, on this atom. And the number of neutrons is 33. We take 60 minus the 27 for the mass that we have in the protons, and we get 33 neutrons. So here is just a little recap on what we've been talking about. When we have a change in the number of protons, if we change the number of protons of an element, we get a different element, right? If we change the number of neutrons in an element, we get an isotope of that element. Now, what if we change the number of electrons in an atom? Well, in that case, we get a charged particle. It's called an ion. And we can have two different kinds of ions. We can have an ion that exists because an atom loses an electron. Here we have a lithium atom. It loses an electron, and we're left with a lithium ion. It's going to be positively charged. Here we have 3 protons, 3 electrons in the lithium atom. In this ion, we have 3 protons, 2 electrons. That leaves us with extra positive charge, a +1 charge to be exact. We don't write the 1 because the 1 is assumed, but we write it lithium with a little plus that's superscripted right after it, and that's the lithium ion. We call a positively charged ion a cation. Kind of a strange name, but that's what they're called. If we have a negatively charged anion, as we do down here, it's called an anion. So those are the terms that we use. Here we have fluorine with 9 electrons, and if fluorine gains an electron, fluorine ends up with 10 electrons. It's no longer fluorine, it's an ion. It's fluoride ion, F with a little minus sign superscripted after it. So we can also have atoms that gain or lose more than 1 electron. Here is a calcium atom, and when calcium becomes an ion, it likes to lose 2 electrons. So it ends up being a 2+, or you could write it +2. Either way, you'll see it both ways. So that's how that ion looks. Another way to write this process is like this. It's just kind of the chemical formula. Lithium, when it loses an electron, will become lithium ion plus an electron over on this side. We have here, just writing it the other direction, fluorine plus an electron gives us a fluoride ion. And you can read the little cartoon. Hopefully those are of some interest to you guys. How do we name ions? This is an important thing to know as well. When we have a cation, remember the positive ions. They're just named after the parent ion. This is a calcium ion. This is a lithium ion. But if we have an anion, the negative ions, those are named a little differently. We add IDE to the root of the parent ion. So you probably heard me I didn't say fluorine ion, I said fluoride ion. This would be bromide ion or sulfide ion. You just add the IDE to the parent atom, and that's what you call the anions. Can we predict if an atom will become a cation or an anion? Absolutely, yes, we can. Not only that, we can predict how much charge it has. Is it a +1, a +2, a +3? And for the most part, there are some atoms, some elements that behave a little bit differently, and there are some more rules that we'll discuss later in chemistry. But for now, we're going to stick with the simple ones, and those would be the elements in these families here. We're going to look at these, and I'm going to explain to you a little bit why elements like to become either a cation or an anion. Right here, remember I had talked a little bit about the noble gases or the inert gases being very unreactive. They don't like to react with anybody else. That's because they're very, very happy. They have a full outer electron shell. Let me explain that. The first shell that electrons occupy in an atom is the lowest shell, the very first one. It has the lowest amount of energy. Once that shell is filled, electrons will fill the next level. It will be the second level. Once that level is filled, it will go to the third level, and then the fourth. Helium, neon, argon, krypton, xenon, and radon have full shells that are outer shells. This one happens to only have 2 electrons. This shell has 1, 2, 3, 4, 5, 6, 7, 8. So we call these octets. When an atom has a full octet, it has 8 electrons in its outer shell, then it is very, very stable. So all of the other atoms would like to have that same number in their outer shell as well. Fluorine. Fluorine, if it could somehow obtain another electron, it could have the same number of electrons as neon and be very stable. It could also lose 1, 2, 3, 4, 5, 6, 7 electrons and look like helium. It would be very stable then too, but that would be more difficult. So the easiest thing for fluorine to do is gain 1 electron. So we know that the halogens here would each like to gain 1 electron so that they could look like the noble gases in what their electrons are looking like. In this family, oxygen would like to gain 2 electrons. So it's going to become an anion with a -2 charge, most likely. And nitrogen would like to gain 3. Here we have lithium. Lithium, instead of gaining 1, 2, 3, 4, 5, 6, 7, it's most likely going to lose 1 and look like helium for its number of electrons. And so it will end up becoming a cation of +1 charge. Elements in this family, we have magnesium or calcium, they're going to tend to lose 2, 1 and 2, so that they can look like a noble gas in their number of electrons that they have in their outer shell. So that is how we know whether someone will become a cation or an anion. Now these are a little bit different. We'll talk about those later because they could either gain or lose. So Those we won't be discussing right now, but as for the rest of the families here, you should be able to predict whether it will become a cation or an anion and what the charge will be. So you try. Write the symbol and name for the ions formed by oxygen, magnesium, and iodine. So go ahead and pause the video and see if you can get those right. So the answers are right here. The oxide ion looks like this. Oxygen with a 2- or a -2. You could write it either way. The magnesium ion, it's a cation with a +2 charge, and the iodide ion just has a negative charge. We don't write the 1 after it. Ionic compounds. Compounds that are formed from ions, basically, is what ionic compounds are, such as a metal and a nonmetal. If you'll notice from the periodic table, the metals tend to form cations and the nonmetals tend to form anions. And here we have an example. We have sodium, which is a metal, and chlorine, which is a nonmetal. And if we look at the ions of each of those, here's the sodium ion and the chloride ion. They will form sodium chloride, which we all know as table salt. And this is what, here are a few rules that are really important. When you are looking at how ions interact and form compounds, you need both cations and anions present, and the numbers of the cations and anions must be such that the net charge is 0. So right here we have a +1 for sodium and a -1 for chloride, and our net charge then will be 0 because we take 1 sodium, 1 chloride, make sodium chloride, and we have a net charge of 0. Well, what if it doesn't work out that way? What if the anions or cations have more than 1 for their charge? Let's look at magnesium. Here's the magnesium cation of +2. Oh, and I realize I made a mistake here. It should be a 2, not +1. That's +2. And we have a chloride ion and a chloride ion right here. Those are each -1. In order for the net charge to be 0, we will need 2 chloride ions and 1 magnesium ion. That gives us a +2 charge for the magnesium and a total of -2 charge for both chloride ions. Now you try. Give the formula for an ionic compound containing lithium and nitrogen ions. Here's your answer. There would be 3 lithiums, 3 lithium ions to the 1 nitride ion, because the nitride would have a -3 charge, and each of the lithiums have a +1 charge. So here are some ideas for 4s that you can look up. Please feel free to answer any other questions you might have, research any other questions for that 4, and I look forward to seeing what you have in class. Thanks.